Okay, welcome to day 17 of 2023 Advent of Code. So this is the last one that I've currently done. I've not done any more after this. So I need to think about what videos I'm going to make next. Any suggestions, please let me know in the comments down below if you watch this. Anyways, let's dive in. So we have lava flowing rapidly. So we have a crucible, into a large crucible. The crucibles are top heavy and pushed by hand. Unfortunately, the crucibles become very difficult to steer at high speeds, so it can be hard to go in a straight line for very long. To get to Desert Island, the machine parts it needs as soon as possible. To get Desert Island, the machine parts it needs as soon... There we go. Completely missing all the punctuation. To get Desert Island, the machine parts it needs as soon as possible, you'll need to find the best way to get the crucible from the lava pool to the machine parts factory. To do this, you need to minimize heat loss whilst choosing a route that doesn't require the crucible to go in a straight line for too long. Fortunately, the elves here have a map that uses traffic patterns, ambient temperature, and hundreds of other parameters to calculate exactly how much heat loss can be expected for a crucible entering a particular city block. So we have these numbers representing the heat loss if a crucible enters that particular row and column. So from the starting point, in the top left city block, the destination, the machine parts factory, is the bottom right city block. So we're going to go from this top left 2 to this bottom right 3. Because you already start in the top left block, you don't incur that block's heat loss unless you leave the block and then return to it. So that's good to know. So the 2 doesn't count. Because it's difficult to keep the top heavy crucible going in a straight line for too long, it can move at most 3 blocks in a single direction before it must turn 90 degrees left or right. The crucible can't reverse direction. After entering each city block, it can only turn left, continue straight, or turn right. One way to minimize heat loss is this path. This path never moves more than 3 consecutive blocks in the same direction and incurs a heat loss of only 102. Directing the crucible from the lava pool to the machine parts factory, but not moving more than 3 consecutive blocks in the same direction, what is the least heat loss it can occur? So we're going to aim for 102, and my full puzzle input of 814. So let's dive into this one. Okay, so we have our total as per usual. I've set up the test already so that we have this we can just run. So let's make a grid. So this is going to be a list of lists. We're going to map int, the function int, over each block, I guess, for row in string dot split lines. So essentially what we're doing here is we're getting all the rows from this, and then we're going to map over it, and because that map is going to get an iterable, it's going to iterate over the string doing int, and that will give us all of those different numbers, and then we're just going to convert that back to a list and put that into the list. Cool, so there's that. So our starting point is 0, 0, okay? So what we want to do is keep track of the direction that we're going and how long we've gone in that direction. We want to keep track of the current cell that we're on. Like I say, the direction movement of row and column. And then we also want to keep track of the total of heat loss that we have. So essentially, we're going to start with a ton of zeros. So we have no heat loss to start with. What we're going to do is going to put all of these in to a tuple. So if we have the row in the column, we have the direction. Currently we're going to go nowhere. We then have the amount of travel that we have done in that particular direction, and the total amount of heat loss so far. So that's going to be the start. So we've got all of these zeros to get us going. Cool. So then the destination is equal to, because we don't know how big the grid is, we want to make it pretty generic. So we're going to go length of the grid -1, and the length of grid 0 -1. So this will be our endpoint. So we're going to have a queue of places that we want to visit, which essentially is going to cover most of the grid. And we're going to go over every item in the queue. So let's make a queue. And this will be equal to just a list, and to start with, we're just going to put the start in there. We're also going to keep a set of scene. So let's just start going over the list. Going over the queue. So while we have something to go over. So we have the row, the column, we have the direction row, we have the direction column, the amount that we've gone in that direction, and the total. If we just, at the moment, it doesn't really matter what order we put it in, but if we assume that's the order of things that we're going to be using, is equal to q.pop. So firstly, we want to check to see if, what if stuff is in the stuff. That was such a terrible thing. So we want to check to see if we have visited this place before in the direction we're going in, the amount of times we've gone in that direction. And if we have, we're just going to carry on. So if the row, the column, the direction row, the direction column, and the number is in scene, and we're going to continue. If the row and the column is equal to the destination, then we are also going to break. So total will then be equal to t, which will be our running total. And yeah, I'm going to break out of it there. So that's our sort of base case, which arguably could have come first, but never mind. Cool. So then we have something we're going to process. So if we say scene.add, and we are going to add the row, the column, the direction row, direction column, and the number that we've got in that direction. Okay, so now we start putting in the logic for where we can move to. So if we're moving in a direction and we have not yet hit the 3 that we can move in that direction, then we can add more or go in that direction more. We want to sort of, well, I say we want to prioritize it. We'll just add it to the queue. So if n is less than 3, and the direction row, direction column does not equal 0, 0. So if we are not right at the start, because we don't want to be going 3 times in the direction of 0, 0, where we're not actually moving anywhere. So the new row is equal to the row plus the direction row. The new column is equal to the column plus the direction column. So if, and then we want to check to see if the new row is greater than 0. So if it's less than 0, we're going to ignore it. And if it's greater than the length of the grid, we're going to ignore it. So then we have length of grid, and then we'll have 0 less than or equal to new column, less than or equal to the length of grid 0. So if we are able to move, then we will append to the queue, and we want to add the new row, the new column, the direction row, the direction column, the number we've gone in that direction, and the total, but this time we want to increment the total because we visited this particular cell. So we want to increase that by the new row that we're on and the new column that we're on. So that would just increase it by that. Okay, so now we've at least carried on in the same direction or covered off the same direction. So now let's check all the other directions. So for new direction row, new direction column in, and if we do 0, 1, 0, 1, 1, 0, 0, minus 1, and minus 1, 0. So this will give us all the different directions that we're going to travel in, but we're going to check that we're not reversing where we are, or going in the reverse direction. So firstly, if direction row, direction column is equal to minus new direction row minus new direction column, or going in the same direction, direction row, direction column, because we've already covered off that above, is equal to new direction row, new direction column. Then we are going to continue. So now we have the new row is equal to, again, row plus new direction row. New column is equal to column plus new direction column. And we can do both things, increment both things here. We don't need to check which one we're doing, because we have increasing by 0 and increasing by -1. So we're going to, we can do this every time because we've got the zeros and the -1s. So we're all good. So if new, so we're going to do the same check as before. So if new row is less than 0, I'm just going to write it a little bit differently, or new row is greater than or equal to the length of the grid, or the new column is less than 0, or the new column is greater than or equal to the length of the grid 0. We're going to continue. Otherwise, if we're all good, we're going to do q.append, and here we are going to append again the new row, the new column, new direction row, new direction column, 1, because we're going to be starting a new direction, and we want the t plus the grid of new row, new column. I don't know why I just did it that way. New column. So that's going to give us that. And then finally, after we've done this, adding to the queue, we then just want to prioritize, or turn this into a priority queue. So instead of using a priority queue in Python, what we can do is do queue is equal to sorted queue reverse equals true, and then we just return the total because we'll be setting that as we did earlier on. So let's see if this works. Okay. Yeah, let's see if this works. No, we failed. 134 versus 102. Okay. Okay, I have gone away and had some dinner, had a little think about this for a couple of seconds, and I figured out what the issue is. So down here, we are sorting the queue, but we're sorting it in terms of row, then column, then direction, row, then direction column, then number, and then total. Where really we want to be doing this by the total, because we want to be minimizing the total to get to the end. So what we need to do instead is pop the total at the beginning of what we're doing. So this is fine, this is still fine. So we just really need to change this this part here. So this will now be t plus grid of new row, new column, and then we can just delete all of that. Yeah, just delete all of that. Get rid of those. Cool. And then we need to do the same thing down here. We want to take this, so what we want to do, want to visually select two closing parentheses. We're going to delete it. We're going to go backwards find to there and go across one, paste. Oh, so close. There. And then we are going to append, comma, get rid of that. Okay, so let's see if this now works. No, it doesn't. So we get 134, 102. Okay, let's see what we're doing wrong. So we have grid starting point, the search starting point. We have the set. We then grab everything out. We check if it is in scene. If it is, we move on. This is our base break condition. I'm going to add this to scene because we're processing it. If the number is less than 3 and the direction row and direction column does not equal 0, 0, so it's not the initial time that we're doing it, because we don't want to go 3 times in the same direction, then we are going to increase the new row and the new column by the direction row and direction column. So then if silly boy, is less than that, and then over here we want to just delete the equals. There we go. Potentially. No. 78 to 102. Damn, what is going on with this thing? Okay. New row. New column. Grid 0. Then we're going to append T plus grid, new row, new column, new row, new column. Oh, we are not moving in the same direction. Is it gonna run? Damn, that's slow. Come on. That seems... Oh, okay. Well, we passed. That seems incredibly slow. Okay, so that's now running the second part because we passed that test. Yeah, so there were essentially just a couple of little issues there where we were getting the number to be greater, the new row to be greater than the length of the grid, which we don't want. Yeah. And then we get 814. And then the other main thing was we were sorting it incorrectly, because we're trying to minimize for the heat loss, but we're putting the heat loss right at the very end, so that's not, it's not getting to that point until much later, or not getting to that value to use as a sort until much later. So yeah. Okay, so let's try part 2. Now, part 2 is essentially the same thing. A little bit different, but essentially the same. So the crucibles of lava simply aren't large enough to provide an adequate supply of lava to the machine parts factory. Instead, the elves are going to upgrade to ultra crucibles. Gotta love the ultra crucibles. Ultra crucibles are even more difficult to steer than normal crucibles. Not only do they have trouble going in a straight line, but they also have trouble turning, of course. Once an ultra crucible starts moving in a direction, it needs to move a minimum of 4 blocks in that direction before it can turn, or even before it can stop at the end. This is a key part here that we need to account for as well. However, it will eventually start to get wobbly. An ultra crucible can move a maximum of 10 blocks without turning. So previously we had a maximum of 3, now we've got a maximum of 10, but we also have a minimum of 4 before we can turn. In the above example, an ultra crucible could follow this path to minimize heat loss. In the above example, an ultra crucible would incur minimum possible heat loss of 94. Here's another example. Sadly, an ultra crucible would need to take an unfortunate path like this one. This route causes the ultra crucible to incur the minimum possible heat loss of 71. Directing the ultra crucible from the lava pool to the machine parts factory, what is the least heat loss that can occur? So we're looking for 94 and 974. So if I just finish what I was doing here, so grab all of this, go to the top, grab, paste, of course, right, let's go back over there. So part 1, visual, go to the end, yank, go to part 2, visual, go to the end, paste, thank you. Okay, then we want to go to the end, and we want to change this to 94 for this particular example. So I'm only doing one of these examples. I'm not going to do this. I'm going to do this example. Cool. Okay, so essentially with this one, there's a couple of small tweaks to make. So firstly, we have our base condition, or our end condition. So we have, if the row and column is the destination, fine. But we also now need to account for, or even before it can stop at the end, it has to have travelled a minimum of 4 blocks. So let's just pop another condition on here. So let's say, and n is greater than or equal to 4. Then we're going to have t, which is great. So then we have this part here. So if we are less than 3, well, now we can actually move a maximum of 10. So let's update that to 10. And then what we want to do down here, so we have to move a minimum of 4 blocks. So all of this stuff here isn't needed and isn't going to be used if we haven't gone 4 blocks in a direction. So if we say if n is less than 4, that's a 5. And we also want to account for the initial starting point, because we don't want to do that minimum of 4 times. So does not equal 0, 0. Then continue. So that essentially should be it in terms of getting to the end. So let's see if that works for part 2. Again, it's going to run quite slowly because it's just this is just a real slow algorithm or slow implementation of it. But yeah, so once this is run, we should hopefully get a passing test. Okay, so I think we're nearly done with the actual run. The test took 0.01 seconds to run. As you can see here, previous attempt took 3.5 minutes to run the test, and I realised the reason why. For some reason, it was running the whole file with the test, which doesn't really make sense to me, but okay. So what I've done is wrapped it in a if name equals main. So this reading the input and running the actual full thing will only run when the test passes. Will only run when this is run as the main file. And also, I've just popped in a little print here just to see what the length of the queue is when this actually finds the solution, and just returning t straight away rather than breaking out of it. This is probably extremely bad practice, but whatever. So the length of the queue, we still have 4,500 items left to process, but we found the solution that we're looking for, which is 974. So yeah, essentially that was what was happening and why it was taking so long. Again, this took just over 3.5 minutes to run, and that was because this is just a really slow script anyway, really slow solution. Yeah, so there we go. Extremely slow, lots of waiting around. But yeah, we got to the end in the end. Yeah, so the modifications we made, just to recap for the second part, were we added this minimum clause, minimum check, so we have to move a minimum of 4 spaces before we carry on. We updated this to 10 because that's now the maximum that we can go. We added this additional condition on the end here, so we have to have moved at least 4 spaces, 4 in the same direction before we get to the end. If we took this off, we would actually get to the end sooner. But this is a condition of the puzzle, or even before it can stop at the end right there. So yeah, that was the only changes we made. This one didn't need much change to be made. much changes to be made. Many changes to be made. But yeah, there we go. Sorry this one's been a bit all over the place. Yeah, this was a bit of a pain, this one. Yeah, as I said, I haven't solved day 18 just yet. So once I've done that, then I'll publish that, and onwards to 25. There's a couple of these that look really quite fun. Like this one, I'm not really interested in doing, but I'll do it anyway. 20. This one does seem quite interesting to me. I would like to get on to day 20. Yeah, so there we go. Thanks for watching the series so far. Like I said, 17 of 25. I might do some other languages as well. Go, Python. Probably, Go and JavaScript or TypeScript. Obviously I've done them all in Go. At some point, I'm going to go back over the previous years as well. Not just yet, but I will find some other things to make some videos about. Thanks for watching. Have a great day.